I'm going to zip through this kind of quickly. So, and you are at the controls, so you can pause, rewind, fast forward, whatever it is that you need to do to ensure that you're ready for this test. Okay, so we have selected values of an unspecified sequence, B sub n. They're given in the table above. If the sequence shown is arithmetic, what is the value of A? All right, so there's a couple of different ways I could go about this. I can find my rate of change and just figure it out that way. We do have an equation that's A sub n equals A sub k plus d times n minus k. So I could do that to find a formula, but it's not asking me for all of this. If it's arithmetic, that means it's linear. So this tells me it's linear, which means I can just use the rate of change for what I have here. And my rate of change then would be 0.5 minus a negative 4 over 4 minus 1. So that is going to give me 4.5 divided by 3. And if I think about money, if I have $4.50 and I divide it by 3, that's going to give me 1.5. So my B sub n numbers are increasing at a constant rate of 1.5. So if I start from here, now this goes from 3 to 4, so I can do it two different ways. I can go from here backwards, or I can go from here forwards. Well, if I take this one, that's 4, I'd have to actually do it, I'd have to take into account that 2 is right here, and then 3, so it'd be 1.5 and 1.5, what actually means I'm adding 3, so that should give me a negative 1. Or I can think about 5 and subtracting 1.5, going back the other way. Either way, that gives me negative 1. Okay. All right, so then on number 2, this says, if the sequence is geometric, which of these could be an expression for the nth term of B sub n? So I need to figure out the R value. Now, this is a multiple choice question. My R value is either a positive 1/2 or a negative 1/2. I don't have to actually go figure that out because those are my only options. And if you have a negative R value, then your signs alternate on your Y values. So I know it has to be a negative, so it can't be either one of those. And then I have a formula that says, for a geometric, G sub n equals G sub k times R to the n minus k power. So if I use this right here, I can say that G sub n is equal to G sub k, which is negative 4 times negative 1/2 to the n minus 1 power, which gives me D. All right, next one. Here's my function. It's in this form. Which of the following is true? Okay. So it's either exponential growth or exponential decay. Remember that we always use our B value here to figure that out. Our A, when we do this, is always going to be positive, so I know it's not D. Now, that is a fraction, but B is greater than 1. I can tell that by looking at it, so I know that that can't be true, so B is not my answer. And if B is greater than 1, it is exponential growth, which is C. All right, number 4. Which of the following is equivalent to this? So the only thing I'm going to change is my B value right there to start with. So it's going to be 2 times, and that can be, instead of 4 to the 2x, it's going to be 4 squared to the x power, okay, which is equal to 2 times 16 to the x power, and that is A. Okay, next page. Okay, so the first thing I want to do is figure out on this one. So it says, what is the value of the limit as x approaches infinity of h of x, where h of x equals this function? So the first thing I want to do is figure out if it is exponential growth or decay. So since b is less than 1, that tells me it is decay. And there is no reflection here, so it is decay. Now, what's happening here is, that's not a really great little sketch of that. I don't know why I'm so tongue-tied right now. So this is what it would look like if I'm just taking these two things into account, all right? So this is as x approaches infinity. Well, as x approaches infinity, we're going here. But this right here is a translation down 2 units. So if this translates down 2 units, it's actually going to look more like this. So instead of x approaching 0, since it's translated down, it's going to approach -2. Okay, got to know our transformations. All right, on number 7. Looks like I lost some fraction bars here. I don't know why that happens sometimes, but it does, so let's put those back in there. All right, the graph of an exponential function k is increasing and concave down. Which of the following could be an expression for k? All right, well, if it's increasing and concave down, or what we can do here is just draw our little sketches, that would help. This is greater than 1, so it's growth. This is also growth, but then it's reflected. This is decay, so it looks like this. This is decay, but then it's reflected, so it looks like this. Okay, so the two that are, so it says increasing and concave down, so let's kind of narrow this down here. This is increasing, this is decreasing, so I don't like that one. Decreasing, don't like that one. Increasing, I like that one. But this one is concave up, so I don't like that one anymore. My answer is D. Sometimes it's good to kind of sketch them all out so you can get your mind wrapped around it. All right, number 9. A data set was analyzed with linear, quadratic, and exponential regression. The residuals for the analyses are given in the graphs above. Based on these, which of the following could be a good model for the data? All right, so let's just first decide which one of these residual plots we like. This one shows a clear pattern to me, so I don't like that one. That one looks pretty random. This one, I see a pattern as well, so I'm going with quadratic. Okay? Nobody's really asking you to write this equation, plus we haven't even talked about logs yet. If you can decide it's quadratic, this is the only quadratic function there is. All right, zombie plague is spreading exponentially such that the number of zombies increases by 95% every year. If the plague is modeled by z of t, where t is measured in days, and z sub 0 is 15, which of the following could represent z? Represent z. All right, well, notice the 15, that's your A value for all of them. So it gave that to me. That's important, but I don't really have to do anything with it, right? And if it's increases by 95%, that means that your B value is going to have to be 195%, or 1.95. That eliminates C, and that eliminates A. Those decimals there, that would be reducing by 5%, and that's not what we want. Okay, so we've got these two. They told us there's 365 days a year. I guess they didn't tell us that, but we're supposed to know that. So I'm either going to multiply by 365 or divide by 365. So this says every year. So if I substitute in a time element for a year, it says this is supposed to be measured in days. So 1 day, if I substitute in 1, if I multiply it by 365, that would give me 365 days. If I substitute in 1 here, I get 1/365th of a year. That is what I want, which is D. All right, so here's our first FRQ. This is non-calculator. All right, so I want to calculate the average rate of change. Average rate of change, that is just slope. And how you show your work for slope, remember, is very, very important. This is the graph of f, and this is my interval. So I want f of 2 minus f of -1 over 2 minus a -1. All right, so f of 2 is right here. F of -1 is right here. So that is going to be 2 minus 16 over 3. So that gives me -14 over 3. That's my average rate of change there. Then using the correct limit notation, I want to describe the left and right end behavior. End behavior. That means I'm going to have the limit as x approaches -infinity of f of x, and I'm going to have the limit as x approaches infinity of f of x. Okay, so for this function, oh goodness, moving the wrong thing. For this function, as x approaches -infinity, f of x is approaching infinity, and as x approaches infinity, f of x is approaching 0. So this is infinity, and this is 0. So I want to find an expression for f based on the graph above. All right, so in order to do that, if this is exponential. It doesn't actually say that, but we can figure out that that is what's happening here with these. We can also figure out what our b value is or what our r value is. Basically, r does equal b. Right, so when I go from 1 to 2, I'm multiplying by 1/2. When I go from 0 to 1, multiplying by 1/2. So there's that. And there's two different forms of this that you can understand, one of which is y equals just a times b to the x, which that is your initial amount. Okay, you can also do it using the formula we used on the other one, where we do like g sub n equals g sub k times r to the n minus k. Sometimes you have to use that. But in this case, we found b, we have that, and we have our initial amount, it's 8. So I can say that f of x is equal to 8 times 1/2 to the x power. I think on the actual paper review, I think I did it differently and then changed it to this one. I don't remember what I did. Okay, so now we're going to let the function h be defined as this, and we're going to use this to get there. So h of x is equal to, well, it's 3 times this f of x, which is this, so it's 3 times 8 times 1/2 to the, but then instead of x, I have to plug in x plus 2. I don't need any extra parentheses because of the nature of multiplication, but that's my answer there. These two I can multiply because there's no little exponent, so this is 24 times 1/2 to the x plus 2 power. Okay, on to here. Selected values of the arithmetic sequence a sub n and geometric sequence g sub n are given in the table above. Determine the value of a sub 4 equals v. Okay, so I'm looking for this, which means I need either to find, I'm going to go ahead and just find the equation. I can find the rate of change, though. My rate of change is the common difference. So that's going to be 13 minus 18 over 3 minus 1, which is going to give me negative 15. Oh, no, not negative 15. Oh, my goodness. Negative 5 over 2. Okay, so that's D, which means that I can then use my formula that is, I'll just write that down first, a sub n equals a sub k plus d times n minus k. And I'm going to use these two numbers here. So a sub n is equal to 18 minus 5/2 times n minus 1. Okay. So if I want to find a sub 4, which is v, so a sub 4 is equal to 18 minus 5 halves times 4 minus 1. Okay, so 4 minus 1 is 3 times 5. That would give me 18 minus 15 halves. And that 18 I can change into 36 over 2. So 36 over 2 minus 15 over 2. So 36 minus 15 is 21. That gives me 21 over 2, and that is the value for V. All right. Okay. Now we're going to determine the value of G sub 1 equals W. Now I'm looking for this one, so I need my geometric. Okay, so since this is geometric, I need my R value. And since they told me it's geometric, and these are consecutive terms, I can figure out my R value right there. I couldn't do that here because this went from 3 to 1 and it wasn't actually the next term. All right, so R is equal to negative 10 over 5, which is negative 2. Okay, and then I have that G sub n is equal to G sub k times R to the n minus k power. And I will use, well, I can't use this one. I like to use the smaller ones, but I can use these two here. So G sub n is going to be equal to G sub k, which is 5, times R, which is negative 2, to the n minus 3 power. All right, so since I want G sub 1, which is W, that's going to be equal to 5 times negative 2 to the 1 minus 3 power. So that is 5 times negative 2 to the negative 2 power. So that's 5 times, well, negative 2 to the negative 2 power, that'd be 1 over negative 2, and I'd square it. It's going to be 1/4. So that gives me 5/4, which is W. All right. Then it says use either values for A sub n or G sub n to calculate the value of U. All right, so now I'm looking for U here. Well, let's see. Let me just do it both ways, and then you can decide how you want to do it. So U is the n, basically. So the value, so my A sub, if I'm going to do, let me do arithmetic first. When I do this one, this is n, this is A sub n, so that means A sub n, which is 3, is equal to 18 minus 5 halves times U, I'll just put that in there, U minus 1. Okay, so I can subtract 18 from both sides. That gives me negative 15 equals negative 5 halves times U minus 1. Then I can multiply both sides by a negative 2/5 to get rid of that fraction there. So when I do that, that's going to give me positive 6 equals U minus 1. And so U equals 7. Or we could use our geometric and say G sub n, which is 80, is equal to 5 times negative 2 to the U minus 3 power. So I'm going to divide both sides by 5 and get 16 equals negative 2 to the U minus 3 power. So to solve that, I want to make this have a base of negative 2, just like this does. And I know 2 to the 4th is 16. Well, negative 2 to the 4th is also 16. U minus 3. And then since these bases are the same, I let 4 equal U minus 3, and U equals 7. All right, next page. All right, now we need our calculator. A radioactive element. Now this is one I sent out a remind about. If we use this exactly like it is, the correct answer is not here. This 85 needs to be changed to 75. All right, radioactive elements. X decays at an exponential rate. The mass in grams of X is present at time t in hours, and all that stuff is labeled up here for me. Using the exponential regression, at what time t will the mass of X be 75 grams? So the first thing I need to do is find my regression. So X of t is what I'm looking for, really X hat of t. I know it doesn't ask me for this to write it down necessarily, but we will. All right, let me get something. I'll have one to look at when I flip. Okay, we are here. So I'm going to add lists and spreadsheets. Go up here, X val. So my X values are 0 and 10. And my Y values. Now I just want you to think of something that doesn't, it's not what this question's about, but if I looked at a residual plot for this, it would tell me absolutely nothing because I only have two pieces of information, right? 138 and 115. Okay. And so it told me exponential, so menu 4, 1, A. There is my function. So that's 138.981. 138.9819 to the x power. Now, remember, I am not typing those numbers back into the calculator. All right? That's why we didn't even necessarily need to write them down, but I just want to make sure everybody's with me. So what I'm looking for, what this is telling me, it is telling me basically that x of t is equal to 75. And what is t? That's what I'm looking for. So if I knew what t was and I wanted x of t, then I would go to my calculator screen and do f1 of whatever. But that's not what this is asking me for. This has given me the y value. When it gives me the y value, I need to look at a graph. So I need to add a graph. Now, notice it popped me into F2 right here. Because F1, it's stored. That's why we don't type things back in. But it's not checked. So I need to hit Enter. And I can't see it, but that's okay. If I need to hit Tab, I can go back up there. I can see that it's checked now. I just can't see it because it's off the screen. And my Y value that they gave me is 75. Okay, so now technically both of those things are graphed. I just can't see them. So let's think about what we have. Right now we have, if you look at your data is going from 0 to 10, and your mass is at 138, and it's going down. So maybe if we did 150 for our Y, and maybe tried 20 for our X, and let's see what happens here. So menu 4, Windows settings, do our X max at, I already forgot what I said, 20, and then 150 here. Let's see what we got. Okay, so I can see them both now, but I still can't see where they intersect. So I'm going to change that 20 to a 40. I just didn't want to go too crazy with this, because then sometimes things get super small. There we go. Now, where they intersect, because remember this red line, that's 75. This is the function here, right? You can even click on it and it'll show you that. But what we want to do is we want to find where they intersect. So menu, analyze graph, intersection, do your little thing, move it so it's to the left of it. You can click on it and then move it over there. Click on it. There's your intersection. So when this is the time, when this is your mass, so that's 33.445, which is B. All right, number 16, the population of deer in a forest is modeled by a team of wildlife biologists. Two function models are created. One is quadratic, one is exponential. T equals 0 represents the year 2020, and T is between 0 and 20. So this right here, this tells me what my domain is on my calculator already. What is the earliest calendar year that the population is predicted by the exponential model exceeds that predicted by the quadratic model, which means I need to look at both graphs. So we are going to start back over. 1, no, and we're going to add a graph. Okay, and so then I'm going to graph the first one, which is 0.21 x squared plus 1.72 x plus 6.18. So let me double check all my numbers here. That looks good. And I'm just gonna arrow down so that I can just, if you hit enter, and then you need to hit tab to get back there, but I just arrowed down there. And then the other one is 5.02 times 1.19 to the x power. Okay, and then I can hit enter. Okay, I can see them both. Not very well, but I can see them. So let's go back over here. So it said t equals 0, what is the earliest calendar year that the population predicted by the exponential model exceeds that predicted by the quadratic model? So when you're on your graph, if you don't know which is which, if you hit tab and you arrow up, you can see that this is that one, and the blue is your quadratic, your red is your exponential. The other way is to click on them here, and you can see what is what. So basically it's saying, when does red exceed blue is what we're looking for. Now, it happens right here, but that makes absolutely no sense because that's negative time, right? And we already know that our domain goes from 0 to 20. So 0 to 20, and I'm going to have to fix my range. So let's just do them both at 20 and see what happens. So menu, or actually, I take that back. Let's look at our answer choices here. Nope, that doesn't really tell me anything else. Okay, so let's go back over here. We'll just do them both at 20 and see what happens. So I want my window, window settings, so 0 to 20, and then I'll just do 0 to 20. I could have left that as negative. I could have left the X-min on both of them. It doesn't really matter, but okay. So I know my X scale is good because I'm supposed to go from 0 to 20. Clearly, I need to go way farther on my Y. So I'm already at 20. They don't look very close up there, so let's go to 100. So menu, 4, 1, change my Y to 100. Boom. Okay, so I can see where they intersect. All right, and I go do my intersection here, menu, 6, intersection. Move this guy over. Don't have to even really be that close. And then move, make sure it's on the other side, boom. Okay, so the first time, well, when they intersect, when they are the same, I have 16 something, comma 95 something. So we got to decide, do I want the 16 number or do I want the 95 number? Neither one of them are my answer choices, but it's asking me for what is the earliest calendar year. Okay, year, that would be my time, and t equals 0 represents the year since 2020. This represents the y value represents the population. So this is 16.937 is what I have, right? So I get t equals 16.937. Remember, the time is the years since 2020. And so the first year, so if I add 20 here, this would be 2036.937. Not that that really makes any sense, but that's when they're the same. So the first calendar year where that would exceed it would have to be C. Okay, so our calculator active free response here says the population of bacteria in an abandoned container of food T days after it was taken out of the refrigerator. I'm sure we've all experienced that. Given by B of T, where B is measured in hundreds. Selected values of B of T are given in the table above. So T is in days, B of T is in hundreds of bacteria, okay? So B of T can be modeled by this quadratic regression. I don't even have to go find it. They're telling me what it is. So I want to find the time T when the population of the bacteria is projected to reach 3,000 according to the quadratic model. Give a reason for your answer. So that means that B of T, when does it equal 3,000. Ask yourself whether or not that is what we are looking for. And, oh, shoot, it's not B of t, it's Q of t. My bad, hang on. Q of t. Because that's the regression. So basically what happened here, instead of doing B hat, it just did Q of t, saying that it's the regression, same kind of thing. Either way, though, that's not exactly what we are looking for, because B of t is measured in hundreds. Hundreds. So what number would I multiply by 100 to get 3,000? And the answer to that is 30. Okay, so really we're using Q of t equals 30 to say that t equals what? That's what we're looking for. So we're going to go to the calculator. 1 for new, no, and then I don't need to add list or spreadsheet. I can just add graphs here. And so I'm going to type that Q of t in here, 0.715x squared plus 1.222x plus 3.708. And then I'm going to arrow down because I've already decided from right here that Q of t, which is y, equals 30. If I have the y value and I want the x value, this is what I do. And this is 30. Okay, I hit enter. No big shock that I can't see it, right? So I'm going to menu, change my window settings. So I just put in y equals 30. So let's go to like 35. See what, there we go. I can see where they intersect. So I can go find so remember the x value is like your t. This just means 30 no matter what. So I need to know what that x value is there. So menu, 6, I want the intersection. Move that to the left. Move that to the right. And I get 5.2693. T equals 5.2693. And I didn't write this question. It says give a reason for your answer. Really, when you're giving a reason for your answer here, basically what that really should say is we need to use the correct units, so t is in days, and that you're showing that you're finding this, Q of t equals 30. Basically just kind of show what you're doing in the calculator. All right, so then I need to find the residual value at t equals 0.2 days. And here, remember I said 3 decimal places unless you're told otherwise. Now, just because it says to round still does not mean that we are using rounded numbers along the way, okay? So this is asking me for the residual. So you need to think for a second. Is the residual actual minus predicted or predicted minus actual? And residual is actual minus predicted. So that means that's B of 2 minus Q of 2. Right? And we're going to round to the nearest 0.01 when we're done. Well, B of 2 I can get from the chart. That is 9.32. And then Q of 2 I'm getting from the calculator. So in order to do that, I need the calculator screen. Add my calculator. So I'm doing my actual, which is 9.32, minus my predicted, which is stored in F1, that is F1 of 2. That gives me 0.308. So the calculator said 0.308, which is 0.31 because of this. All right, so does this indicate that your quadratic model is overestimated or underestimated? The actual bacteria. So if this is my line, which I know isn't really a line, but it doesn't matter, I have the actual has to be bigger than this because I got a positive number. And I also want you to think about if I was to take this and I have some point and some point here, when we laid it out, that's how we got our residual plots. And if the number's above it, that's how I get a positive residual, and this is how I get a negative residual. And so you can see the line right here, it's underneath it. So if it's positive, the line is underneath it. That means that the line itself, or the curve, is an underestimate. So we could say it's an underestimate. And then my justification is that residual is positive. All right, now it says that B of t can also be modeled by L of t in a linear regression model where A and B are constants. Now, we've been doing where the variable comes second. This one shows that it comes first. I'm not sure that it would really matter. When you're writing it out, it's not asking us to write an equation. It is just asking us to find A and B. So you need to make sure that you understand which is A and which is B, right? A is actually your slope, like maybe it's not a bad idea to choose that one here, so you're not trying to mix it up with the A and the B in the calculator. So once we go here, all right, so I have this and I have this. I can do my little chart now. I don't necessarily have to start over brand new. I can just add a document, and I'm going to add my lists and spreadsheet. And let's see, let's type this in. And this is going to be 0.5, 1, 5, 2. Y value. Okay. All right, there we go. And so I want to do a linear regression, stat calculations. Now, remember what I just said. If you look at your paper and look at this. If we look at this for a linear regression, which we've been using, the A and the B on this number 4 is different than the A and the B on the paper. And that's going to happen. I mean, I can't guarantee everything you're going to see. So you just need to understand it's not just truly A and B. The way it's written on the paper, if we looked at 3, M is A and B is B. So maybe this time I choose 3. It's up to you as long as you can keep it straight. And then I'm going to do X value, Y value. And then notice on here also, it says it's going to store it in F3. Because remember, we have stuff in F1 and F2. So if we need this, it's in F3. Not a bad idea to say, all right, well, this is in F3 kind of for yourself in case you need it. We don't need it, but that's just a little side note there. And so when I do this, then I scroll up so I don't grab these weird R numbers. So this is my A, this is my B. So A is equal to 4.4397, and B is 1.0267. Okay. All right, so then it says, and that's all it asks for. It doesn't say to write the equation, so we don't need to worry about that. Okay. The graphs of the residuals of the two models are given below. Based on these graphs, which model is more appropriate for the data? Explain your reasoning. Okay, so I feel like between L of t and Q of t, this, I see a pretty clear pattern there. This is random, and yes, it goes up, down, up, down, up, down, but that's not a pattern, okay? And so I would need to say, because it does say explain your reasoning, I would say Q of t, the quadratic model would be more appropriate. Because that residual plot does not show a pattern. And remember that this review is not the end-all be-all to everything. There is stuff in Albert for you to look at. There's stuff in AP Classroom, all of your assignments. all of your notes. There are tons of things for you. Just make sure that you are ready for this test.